Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on January 8, 2026, about 4 days ago. It demonstrates a new framework that boosts geolocalization accuracy within 500 meters from just 8% to 22%, significantly outperforming top models like Gemini 3 Pro. The paper is titled, Thinking with Map, Reinforced Parallel Map-Augmented Agent for Geolocalization. And as we'll see shortly, the combination of agentic reinforcement learning and parallel test time scaling offers a fascinating look at how models can verify their own location hypotheses. And for those interested in the implementation, the authors have shared their code on GitHub. Figure 1 illustrates the complete workflow and its resulting performance. The top diagram breaks down the process where the agent identifies visual clues, such as a distinctive tower or a bar sign, and then uses specific tools like keyword search to gather facts. This leads to a summary and check step, where it queries a static map to verify that the spatial relationship between these landmarks actually exists. Below, the bar charts compare this approach against state-of-the-art models on 3 benchmarks. On MapBench specifically, the parallel version, shown in dark blue, reaches over 22% accuracy within 500 meters, clearly surpassing Gemini 3 Pro and GPT-5. Figure 2 details the parallel sampling process. The diagram contrasts 2 reasoning paths starting from the same question. In the top row, the evidence-ungrounded trajectory fails because the tool responses do not logically support the final red answer, marking it as non-causal. Conversely, the bottom row shows an evidence-grounded trajectory. Here, the tool outputs directly support the conclusion, creating a valid causal link that allows the verifier to trust this result. Table 1 lists a suite of tools that the agent uses during the Thinking with Map process. At the top, the image zoom tool allows the model to inspect fine details within the original picture, much like a human zooming in on a distant street sign. Following that, a set of POI tools, covering input tips, keyword search, and detail queries, lets the agent retrieve text data about potential landmarks. Finally, the static and satellite map query tools provide visual verification by generating map images that the agent can compare against the original view. So, Figure 3 visualizes the entire framework, showing how these tools fit into the agent's reasoning loop. On the left, Panel A maps out the core process, where the model proposes a hypothesis, calls a tool, and then uses the response to update its internal candidate pool, repeating this until it converges on a location. To build this capability, Panel B in the top right depicts the training phase, which uses reinforcement learning to reward trajectories that successfully find the target. Then, Panel C shows the deployment strategy, where the system runs multiple reasoning paths in parallel and relies on a verifier to select the most accurate final answer. Table 3 details the geolocalization results on the MapBench dataset, separated into easy and hard samples. The columns measure accuracy at varying distances, starting from a tight 500 meters. Looking at the top block, Gemini 3 Pro with Google Search achieves only about 4% accuracy on the hard set at this finest scale. In contrast, the bottom section highlights the gains from the new framework. The final configuration, utilizing reinforcement learning and 4 parallel agents, jumps to nearly 15% on the hard set and roughly 45% on the easy set. Moving on to Table 4, the evaluation expands to 2 external benchmarks, GeoBench and Image02, to verify worldwide performance. The table splits results by dataset, with GeoBench on the left and Image0 on the right. In the top block, the best closed-source model, Gemini 3 Pro, manages about 38% accuracy at 500 meters on GeoBench. In contrast, the bottom section tracks the gains from the proposed method step by step. The base model starts at only 12%, but adding the map tools instantly boosts this to nearly 50%, and the full parallel pipeline ultimately reaches almost 58%. Wrapping up, 2 takeaways stand out. First, equipping agents with map tools enables them to verify visual clues, solving fine-grained localization tasks where standard models struggle. Second, the success of parallel test time scaling shows that agentic workflows, where models explore and cross-check multiple paths, are essential for high-precision reasoning. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.